Okay, let us discuss now a few questions on the topics we have discussed so far on photons. First is a very simple question. How many photons are emitted per second by a 5 milliwatt laser source operating at 632 nanometer? So wavelength of the source is given. So from here we have calculated the energy of one photon. How much is the energy of one photon? We have found it to be hc by lambda. This is the calculations. You will understand it easily. Now we have to find number of photons per second. How will we find number of photons per second? We know the energy of one photon. We know the energy released by the source every second, which is power. Power means what? Energy per time. How much is that? 5 milliwatt means 5 into 10 to the power minus 3 joule every second. So therefore number of photons will become power divided by energy of each photon. For example, this is the example we have taken. Suppose a source is releasing 100 energy every second and energy of one photon is 2. Then in 100 how many photons will be there? In 100 energy how many photons will be there? Energy of one photon is 2. How many photons will be there? 50 photons. Okay, now from here let me go to another questions. Here is the question. The sun delivers about 1.4 kilowatt per meter square of electromagnetic flux to the earth's surface. Calculate the total power incident on the roof which is having a dimension of 8 meter by 20 meter. Number B, the solar energy in joules incident on the roof in 1 hour. And number 3 is the radiation pressure and force assuming the roof to be perfectly absorber. First point is about the total power incident on the roof of dimension. Total power. Okay. What is given in the question is intensity. Intensity we know energy divided by area divided by time. Clear? And if we have to calculate power is nothing but energy divided by time. So this is nothing but intensity into area. So the first question we get by multiplying intensity, because this is intensity, energy per second per meter square. How much is that? 1.4 into 10 to the power 3, and area is what? 8 by 20. 8 by 20. This is the power of the incident radiation. This will come out 2 to 4 kilowatt. Similarly, in the second point, the solar energy in joules incident on the roof in 1 hour. Solar energy, we need energy. Energy is nothing but power into time. You have the power 2 to 4 kilowatt. And in how much time? 1 hour. 1 hour means 60 minutes and 1 minute means 60 seconds. So kilowatt hour into this is second. So when you multiply this one, you are getting 2 into 10, this is into 10 to the power 3 will be there. This will come out as 806.4 million joule. This is the answer of this one. You calculate it, you will get this answer. Number C, the radiation pressure for what surface? Assuming the roof to be perfectly absorber. For perfectly absorbing surface, radiation pressure is nothing but I by C. You have the value of I, you have the value of C, you got your answer. 4.7 into 10 to the power minus 6 Newton per meter square. Similarly, if you have to find out the force, multiply this pressure by area. Multiply the pressure by area. Or you can write I A by C. You have the value of IC, 4.7, 10 to the power minus 6. Area is how much? 8 multiplied by 20. So this is coming out to be 7.52 into 10 to the power minus 4 Newton. Clear? So this is the second part of the questions. Another question is about, just 2 more questions. A bulb emits light of mean wavelength 4500. 4500 angstrom. So lambda is nothing but 4500 angstrom. It is given. The lamp is rated at power of the lamp 150 watt, and 8% of the energy appears as emitted light. Okay, 8% of the power is usable. Okay, so here you will use the word usable power. Usable power is what? 8% of 150 watt. 8 by 100, 150. This will turn out with 12 watt. 12 watt is nothing but equal to your usable energy. So we have to find out the number of photons emitted per second, means number of photons present in 12 watt of energy. 12 watt means joule per second. Okay. So therefore, number of photons, how much will become here? Number of photons will become useful power divided by energy of photon. Yeah, useful energy of, so this is 12 watt divided by energy of one photon. We have to calculate what is the energy of one photon. Okay, hc by lambda. You have the value of h, you have the value of c. Lambda is 4500 into 10 to the minus 10. Okay, right, this is, we'll have to use it 12. If you bring these values here, divided by h 6.6, 10 to the minus 34. Okay, c is 3 into 10 to the power 8 is divided by lambda. Lambda will go up, that is 4500 into 10 to the minus 10 angstrom. So this will turn out to be 27.17 into 10 to the power 18. This is the number of photons emitted every second. Okay. Another question. A small plane mirror, perfectly reflecting mirror of area and mass m is hanging. So there is a mirror which is hanging from here, and the area of the mirror is a, mass of the mirror is m, so mg will be acting on the downward directions with the help of a massless string. The string is massless. Light of intensity I is incident perpendicularly on it. Light is falling on it, radiation is falling on it. Find the angle made by the string with the vertical string. How much angle the string? Okay, fine. When the radiation is falling on this particular mirror, the radiation will exert a force on the mirror, as a result of which this will go in the backward direction. That means some of the picture will become like this, some of the picture will become like this. There is a force, but this force is due to radiation. So how much angle it will make with the vertical? This force is due to radiations, and gravitational force mg will be along these directions. So you have to find a value of theta. So how will you get it? One is like this, the other is like this. This is the third force. There is a tension that will get developed in the string. There is a tension, there is a force. It is perfectly reflecting, so that is why this is the perfectly reflecting surface. Your total force will become twice I A by C force. In the downward direction there is your mg. So if you see this is theta, then we can assume this is also going to be theta, alternate interior angles. So this t we can resolve into two components, t cos theta along this direction, t sin theta. Now since this is in equilibrium, net force will have to be 0, so this component should be balanced by F and this component should be balanced by mg. So we got to t sin theta is equal to F, that is twice I A by C, and t cos theta is equal to mg. So you divide one by the other, tt cancels, sin by cos is equal to tan theta, this is cos, sin by cos is equal to tan theta, twice I A divided by mg. See, from here you got the value of theta, tan inverse twice I A by mg. See, I hope you have understood it.